bring them down. Okay. Let's start with part one, which is the identities. Okay, so these are Pythagorean identities. Okay, the first thing I want to show you is where they come from. Okay, like why, and it's neat to know where it comes from. Okay, if this was like an AP course, we would dive a lot more into that. But here, just so you have a general grasp. Okay, so you guys remember the Pythagorean theorem is a squared plus b squared equals c squared, right? And that's used to find a side of a right triangle, right? If they give you two of the sides, you can find the other side. That's what that's used for. So right here, what I drew is the unit circle. Remember, we use this a lot all the time, right? That's called the unit circle. The reason it's called the unit circle is because from the middle to the edge, which we call that the radius, okay, the radius of a circle, for this circle where we did all our identities was 1. Remember, that's why, I don't know if I'm making connections with you. Remember, it only goes from -1 to 1 because that's the radius, okay? So if I make a triangle off of this, like this, so I make this triangle right here, okay? This is a right triangle. Now, if you remember also from this, remember, cosine was the x and sine was the y. You guys remember that? So check this out. The bottom, what color should we use here? This piece of the triangle is cosine x, and then this piece, the height would be sine x, because this is the x, that's the y. Okay. So it is a right triangle, and that's why we can use, we apply this Pythagorean theorem to the trig triangle inside of the unit circle. So if we put those two things together, this is what you get. Cosine squared, that's this side, plus this side, sine squared, equals the hypotenuse, c. C is the hypotenuse, which really would put 1 squared, but what is 1 squared? 1, so we just put 1. Okay, so this is your main identity. Okay, all of these, even though they look very different, they all come from this one. Okay, and that's what I'm going to show you how to do. So on your paper, they fit nicer, I think, better if you put these three like next to each other. So like this one here and this one here, like this. For me, I can't fit them all like that on the TV, so I'm going to go down, but I think it's better for you if you put them sideways, okay? So here we go. Here's the first three. Okay, so I'm going to number them. I'm going to put 1. They're not really numbered, but just so we can communicate with each other. Is the main one, okay? Cosine squared x plus sine squared x equals 1. And of course, for x, we could use theta or beta or any thing for that angle. Okay. Okay, number 2, it's the same one, but on this one, if you notice, what's isolated is the 1. The 1 is by itself. So let's isolate something else. How about, what if I want cosine by itself? We just have to move the sine. How do we move a sine to this side? Subtract it, right? So it's a cosine squared equals 1, but we move the sine this way, so it becomes minus sine squared x. And there's your second one. See, it's not a whole new one. It's just the first one rearranged. Okay. And what's different about this one isolates cosine squared x. Okay. The third one, again, we go back to the very first one. I have the 1 isolated, I have the cosine isolated, now let's isolate sine. Okay? So I want sine by itself. So that means I want to move cosine to the other side. So since it's a positive cosine, when you move it, it becomes a negative cosine. And there's your third identity. See, and it looks like they're all different ones, but it's the same one. See, it's the same one. I just moved it around. Okay. Okay, so let's go now to the next section. Okay. I'm going to write the first one again. This is the first one. Cosine squared x plus sine squared x equals 1. Because if you look at these middle ones, it's like, that doesn't look anything like that, right? But here's, what if we divide? You can divide by whatever you want as long as you do it to every piece. So what if I divide all of these by cosine squared x? That actually gives us our fourth identity, okay? Because what's cosine divided by cosine? 1, right? Anything divided by itself is 1. What is sine divided by cosine? Look over here. 10. Okay, so now that kind of throws some students off because when you look at these, they're like, but those aren't squared. It's true, but if this one's squared, you just put squared on those. So these two switch for tangent squared. And then where do you see 1 over cosine? Secant. So secant squared. And there, guys, there's your fourth one. Okay? It looks very different, but it's, again, the same one. You just divide it all by cosine. Okay? And now we're going to do what we did earlier. So this one isolates secant. So now let's isolate the other parts. So for example, number 5, and these may be in a different order than I wrote them here, but the point is you're just isolating. So if I want to isolate the 1, I just move the tangent to this side, right? So secant squared x, move the tangent, so minus tangent squared x. And there's your fifth one, which is the same as the fourth one, but you just moved a different part. Okay. Sixth one. I've isolated secant, I've isolated 1. Let's isolate tangent. Okay, so tangent squared x equals secant squared x. But I need to move the 1 to this side to get tangent by itself. So minus 1. And this one has tangent isolated. So again, it's the same one, it's just moved around, right? So it looks like a bunch of different ones, but they're the same one, okay? Okay, so how do you figure we're gonna get this last set? If we divided that one by cosine to get these 3, common sense is we divide by sine to get all the other ones. Okay, so that's exactly what we do. So I'm gonna write the first one again. Remember I told you they all come from this one, all of them. Okay, but this time we divide by sine. Okay, so sine squared x, sine squared x. Now guys, I could have even made a copy of this and just gave it to you, okay, or we could just wrote them down, but it's important that you see where they come from, that it's the same one. It's the same one. They all came from this one. Okay. So here is, what is this, the 7th one? 6th one? Yeah, we're at 7th. Okay. So who is cosine over sine? Cotangent, right? Cotangent. Squared x. Sine over sine is 1. And who is 1 over sine? CSE, cosecant. We don't use those words every day, huh? It's like, give me a cosecant large with the fries. It's not in our regular vocab. Okay, 8. So this one isolates the cosecant. Now just the other two is just isolate 1, isolate cotangent. So if I want, I don't know, cotangent by itself, again, these might be in different order, and it's okay. We just move the 1 to this side, so minus 1. There's cotangent. And then last one, if I want the 1 by itself, I just move cotangent to that side, right? So 1 equals cosecant squared. Move the cotangent to there, so it moves, so it's negative. This one isolates the 1. And there it is. There's all 9 of them. Okay, so notice all 9 of them come from the first one. Okay, so in reality, you only memorizing 1. If you know 1, you know all the other ones. Does that make sense, guys?
Yep.
Okay, now here's something really important. All we're going to do with these is simplify, okay? But I want to give you my teacher glasses so you can spot when to use what. So you notice these, the new ones we learned today, okay? They're all composed of adding, subtracting, subtracting, adding, subtracting, subtracting. So that's what your eye says. So if it's a subtraction addition, it's probably one of these. Because these, notice there's no subtraction or addition. They're multiply and divide, okay? And the other part is, notice all of these are squared. Okay, so just kind of how to spot the difference, okay? Okay, let's begin to I'm gonna separate the video for the examples.